Hello students, today we are going into trigonometry, a topic that a lot of students are always very scared about. They just freak out when they hear trigonometry. Hopefully by the end of this series of lessons, you will be able to take away that fear and turn it into some success. Alright, a lot of times the trick is draw some pretty pictures so you can visualize what the hell is going on. Once you can see what's going on, then you can form a strategy into solving those problems. Alright, so for today's lesson, I'm just going to go through a review on what you need to know already. So there will be some stuff from junior maths, there will be stuff from last year in year 11 that you should have known up to this point. So it will be a review lesson, and to make sure we are all on the same page before we go into the topics that we are going to learn for year 12. Alright, so let's get into it. Good luck! Right, back to our favorite document, the syllabus. So we're looking at unit 4 topic 2 now for trig functions 2. Today, or for this lesson, I would like to cover the first 2 dot points. Recall sine, cos and tangent as ratios of side length and in right angle triangle. That's year 9 maths. Nothing difficult. I'm not going to spend a lot of time on it. The second bit would be understand the unit circle definition of cosine and tan. So we're going to go back to our pretty circle with radius of 1. We are going to talk about the periodicity, how those functions repeat itself using degrees and radians. So you need to be able to remember what radians are and how to convert between the two. Okay, back to year 9 maths. Sokotoa. Sine would be the opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan is opposite over adjacent. If the angle is here, right, this side would be the adjacent, the opposite side would be the opposite, the longest side would always be the hypotenuse. I'm not going to spend much time on it. You need to know that. So you remember it by Sokotoa. This is not on your formula sheet. You're in year 12 maths methods. You need to know this. A super quick warm-up just to start your brains. Work out the unknowns. Pause the video because the answers is going to show up next. Shouldn't take you more than 2 minutes. Here are your answers. Alright, so let's review our unit circle and radian. We have touched on this last year, but I think this is a good time for us to have a quick revision on what that is all about. Unit circle, why do we use it? What is it? It's just a circle with a radius of 1 unit. The reason why we use it is it makes our math much easier when we want to use it to investigate, to study the relationship between cos, sine and tangent. And what is a radian? A radian is the angle formed at the center of any circle by the radii, the singular form of radius, meeting an arc that is the same length as the radius of the circle. It sounds like a mouthful. That is the official definition of a radian. But what he's saying is if we have the radius here, the radius, actually let me just bring up the laser pointer. So if we have the radius and the arc are at the same length, then that angle, we define it as a radian. So that's what he's saying. If the length of the radius and the arc length is the same, that angle would be 1 radian. So how is that relevant to us? Well, radian, we can, in methods or in advanced maths, a lot of times we would use radian to represent angles rather than degrees. So we need to be able to convert between the two conventions. How do we convert between radians and degrees? Let's look at how we do it. Let me just bring the pen back up. So, you know the circumference of a circle, right? A circumference of a circle would be 2 pi r, but for the unit circle it would be 2 pi, right? Because radius is just 1. If you think about it, if the radius is 1 unit, then the circumference would be 2 pi unit. And the angle at the center of the circle would be 2 pi radian. So if we have a whole circle, that radius, that angle at the center of the circle would be 2 pi radians. Sometimes we'll write it like that. A lot of times we will just even ignore this sign. We can just write 2 pi. People would know you're using the radian mode rather than degree mode. So, all right, so 2 pi radians equals to 360 degrees, right? So if we know 2 pi radian equals to 360 degrees, then we know pi radian would be 180 degrees. So this is the conversion that you need to know when you are asked to convert between the two conventions. Okay, so as we have established before, this is the formula you would use. If you want to convert radians to degrees, you use this formula, right? If you want to convert from degrees to radians, you're going to use this formula, which is just rearranging those equations. Very simple. So we'll do some really quick examples on how to convert between the two. So part A, 60 degrees to radians. So when I want to convert, the way I will remember it is I don't want degrees in my answer. I want radian in my answer. So I know I need to divide it by something in degrees. So then the degrees will cancel out, right? So we know it's going to be pi over 180. The degrees would cancel out, right? 60 and then 180 becomes pi over 3. So your answer would be pi over 3. If you are super keen, you can write the radian sign, but pi over 3 is sufficient for your answer. So that's how you remember. Sometimes you think, oh, is it pi over 180 or is that 180 over pi? Well, it depends on which one do you want to get rid of, right? So I will show you what I mean. Let's look at part B. 2 pi radian over 3. I want it to be in degrees, right? So I don't want pi to be in my answer. So I know it has to be 180 degrees over pi radians, right? Because the radians are going to cancel out, leaving my answer in degrees mode. So they will cancel out. 2/3 of 180 would be 120 degrees, right? Simple enough. Let's do a slightly harder one. So let's look at C. First, there are 2 steps. He wants you to convert to degrees first, then calculate the value of sine of pi over 2. So I want pi over 2 in degrees. So how do I do it? Well, I'm going to multiply by 180 degrees over pi. Right? So I know the pi's are going to cancel out, so leaving me with 90 degrees. Then it's asking you to state the value of sine pi over 2. So you know sine pi over 2 means sine 90 degrees. So hopefully by now you would know sine 90 degrees would be 1. And that's how you do this question. Okay, so these things, if this is in a non-calculated exam, you need to know these important values. So these are some of those special angles or those important angles that you need to know. All right, 180 degrees is pi, 90 would be pi over 2, and so on. So these are the special angles that a lot of times you're expected to know what is the exact value if I take the cos of that, if I take the sine of that, if I take the tan of that. All right. Okay, so let's go back to our favorite circle, the unit circle. And we're going to do something interesting here. I'm going to join a line from the middle to a point on the circumference. Okay, let's just call the center P. We'll call this point P, and we'll have theta. So what are the coordinates of this point? What are the x and y coordinates of this point? How would you be able to find out? You know the angle, you have theta, right? You use trigonometry, right? So I'm going to draw a line, let's say an imaginary line here. this x coordinate would be from here to here, right? From here to here. And this y coordinate would be from here to here, right? You can see that it's just a right angle triangle. Okay, so what would you use? We can use, remember it is also a unit circle, which means this length is 1. So if we know the hypotenuse and we know the angle, we should be able to find x and y, right? This is just x, this is y. So what would x be? Sokotoa, right? So we want to find this length. We've got, this is the unknown. I've got the hypotenuse, I've got an angle, I'm going to use cos, right? Cos theta equals to x over hypotenuse, which is just 1, which means cos theta equals to x. So this length is actually cos theta. What about y? What about this length? Which one do we use? We use sine, right? Sine theta equals to y over 1, which is just y, right? So we know this length is sine theta. So the coordinates of this point, P, would be cos theta sine theta, right? Okay, so that's how we develop sine and cos from using the unit circle. And this is a much nicer picture for you to take notes. All right, again, very important. The x coordinates is always given by the cos theta, and the y coordinate is always given by the sine theta. Let's go back to year 11. You have learned about these boundary angles. Remember, sine would give you the y coordinate, cos would give you the x coordinate. So let's look at sine 0 degrees. 0, so the angle is 0. So if the angle is here, which means, well, we don't even have a triangle, which is just a line here, the y coordinate for this guy would be 0, right? It has to be 0. But if we look at cos, because cos, we're looking at the x coordinate, cos would be 1. Remember, we're using the unit circle. So now let's look at sine pi over 2. Pi over 2 is just 90 degrees. Remember, pi is 180 degrees, so pi over 2 is 90 degrees. So sine over 2, pi over 2 is up here. So if we're up here now, y coordinate would be at 1, right? So sine 90 degrees has to be 1. But the x coordinate here is 0. So cos 90, cos gives us the x coordinate 0. Now let's look at sine of pi. What is pi? Pi is 180 degrees. 180 degrees, I'll just bring up my pen, is here. Right, that's 180 degrees, or pi. So sine gives us the x or y, or gives us the y coordinate, right? But we are talking about here, so there's no y coordinate was 0. What about cos? Cos gives us the x coordinates, but this time we are going in the negative direction, right? Which means cos of pi would be -1. Simple enough. Let's look at one more or two more. Next one would be sine 3 pi over 2. 3 pi over 2 is 270 degrees, which is here, down here. So down here, our y coordinate, which is sine, would be -1, right? We're going down by 1. But the x coordinates, well, we're still on the y-axis, which means x coordinates has to be 0. So that's why this is 0. And now we look at 2 pi. What's 2 pi? 2 pi is 360 degrees, which means we have come a full circle, right? We're back on here. So 360 degrees is really the same as 0 degrees, right? If we take the sine or we take the cos of it. So sine 2 pi is the same as sine 0 degrees. Right here, sine is the y coordinate. We will have 0. If we're talking about the x coordinate, which is the cos of 2 pi, then we're going to get 1. And then we keep going. So you can see, what about if I have sine 450 degrees? What do you think that would be? Right? Have a think about it. But this is very important. You need to know these exact values by now. Okay? Because these questions can come up in your non-calculator exam. So you can't check with your calculator. You need to understand what these values would be. Okay, so now we're going to look at tangent. What is tangent? I'll just bring up the pen. I'll write down the definition for you. So if you look here, you can see T and S. This is the tangent. This is the tangent of the circle. Right? This is a circle. It's a tangent of the circle that intersects with the x-axis. All right? And then we have this angle TOS. We call it theta. Okay? So, using the unit circle, the vertical distance TS, which is this guy, is defined as the tangent of theta. All right? I'm just going to write that down for you. So, the vertical distance VS is defined as tangent of theta. All right? So, let's look at this picture. Continuing from the last slide, we're still talking about this length TS, right? Remember, we have developed. Let me just get the pen out. Tan theta is TS, right? From the last slide. We also know, let's look at the triangle OPR. So we're looking at this triangle OPR, the small triangle, the triangle that we have been playing with a few slides ago. Right? Using Pythagoras, you can see, I'm just going to bring the pen back up. Oh my god, it's so hard to just keep changing them around. Alright, so using Pythag, we know PR square, right? PR square, this length, plus OR square equals to OP square. Okay? Right? It's just A square plus B square equals C square. So you can see, but what is PR? This length is sine theta square, right? Plus cos, because OR is just cos. We have developed that before. Let me just write it nicer. Cos theta square equals to, what's OP? OP is just 1 square. Right? So we have developed, this is called the Pythagorean identity. Okay? You need to know this. Sine theta square plus cos theta square equals to 1. Alright? So what else can we do with this? Alright, so if you look at our unit circle again with all that with all the stuff on it, so you can see this smaller triangle and I've got a bigger triangle, right? Can you observe what are these two triangles? What's the relationship between these two triangles? They are similar triangles, right? They have to be similar triangles because, have a look at it. Similarities of triangles, right? These three triangles would have 3 equal angles, so they have to be similar. All right, so I've got two similar triangles. What can I do with it? Let me just get the pen back up. All right, so I'm just going to write the notes here. So triangle OPR would be similar to triangle OTS, right? So if you know these two triangles are similar, then you can see the ratio, if we are from this length over TS over OS, so this length divided by this length would be the same as this length divided by this length, right? Because they are similar triangles, so the ratio between the sides would be the same. So let me just, so TS over OS, right, this length divided by this length would be the same as PR over OR, like would be this length over this length. Okay? So what is TS? Well, we have already developed TS is tan theta, right? TS is tan theta. What's OS? OS is just 1. We are using a unit circle. You can see the beauty of unit circle. It makes the math so much easier. PR, we talked about it before. PR is just sine theta. OR would be cos theta. Therefore, we have identified, or we have developed another relationship. Tan theta equals to sine theta over cos theta. Another very important relationship that you need to know. Okay, I'll leave it to you to read this, the boundary angles for tan. How did we develop these? Well, again, from the last slide, we have developed tan theta equals to sine theta over cos theta. So you should be able to use that to develop this, right? If at 0 degrees, let's say tan 0 equals to sine 0 over cos 0, right? And sine is 0, sine of 0 degrees is 0, cos of 0 degrees 1, so it means it has to be 0. I'll do one more with you and then you can do the rest. What about tan pi over 2? Pi over 2 is the same as 90 degrees, right? So it's asking for tan 90 degrees. What is tan of 90 degrees? Is equal to sine of 90 degrees over cos of 90 degrees. Sine of 90 degrees is, what is it? Well, it's 1. What's cos of 90 degrees? Cos of 90 degrees is 0. And 1 divided by 0, what is it? Is it 0? No, it's not. You can't divide anything by 0. It is undefined. Alright, mathematician still hasn't figured out what do we call something divided by 0. Alright, so because cos 90 degrees is 0 and we're dividing by cos 90 degrees, so we're dividing by 0, which means tan pi over 2 would be undefined. Alright, and I want you to try for tan 3 pi over 2 and tan of 2 pi. Try them yourself and verify these boundary angles. So let's look at periodicity of trig functions, or an easier way to say is because trig functions repeats itself, they're periodic. So we would actually have infinite number of solutions when we have a general equations concerning trig functions. What am I saying? Let's say if I have sine x equals to a, right? And I want you to solve for it. When would x be? Like, what would x be for this equation to be true? Right? We know a sine function looks like this, right? And let's say a is here. So what is the solution? So you can say, oh, this is the solution. This is the point that sine of x equals to a. This is the point that sine of x also equals to a. This at this point, at this point, and at this point, and at this point, and so on. So actually, we would have an infinite number of solutions, right? Okay, so this is the fact that you need to know. When we have a trig function, there would be an infinite number of solutions. So a lot of times when we ask you to solve for a trig function, it will give you a domain, Like, tell me all the solutions between 0 and 2 pi, or between 0 and 4 pi, or whatever, right? So you are not going to list infinite number of answers. So, for example, if I give you an equation, sine x equals to root 3 over 2. Because you guys are so diligent, you would have remember sine pi over 3 would equal to root 3 over 2, right? As I said many times, these are the exact values that you need to remember. So, sine of pi over 3 would give me root 3 over 2, okay? All right, so this is one of the solution. But is there an other solution? Is there other solutions that we can solve for? Like we know x equals to pi over 3 is a solution. But what else? Well, just looking at this picture itself, you can see this length, right, to get this is the same length as this, right? Which means this is another solution. So this angle would be another solution, right? So sine, what is this angle? Well, we can't write pi over 3, but we can write this as pi, which is 180 degrees, take away pi over 3, which will give me this angle, right? Pi, and then take away pi over 3 would give me this angle. Because I know taking the sine of this angle will give me this length, right? Equals is the same as this guy. So I've got another solution here. X equals to pi, take pi over 3 is another solution, right? Or pi take away pi over 2 pi over 3 is another solution. Do I have another solution? Yes, I do. Where is it? Well, if I go a full 2 pi, right? And then another pi over 3, right? Because as I said, if you have one full revolution, the angle don't change, right? So my angle could be this whole bloody thing and then pi over 3. And if I take the sine, if I take the sine of 2 pi plus pi over 3, I'm going to get the same thing. I'm going to have the same thing as pi sine over 3, which means 2 pi plus pi over 3 is another solution. Can you give me another solution? Yes, I can, because if I go, okay, one full revolution, and then I go up to here, right? That would be another angle. That would be sine, well, if I go, that would be the same as going one full revolution, that's 2 pi, 3 pi, and then minus this bit, right? So I can have pi sine 3 pi take away pi over 3. Again, that would be another solution, right? So 3 pi take away pi over 3 is another solution, right? So I'm sorry that this is really messy, but it doesn't matter. What I'm trying to show you here is there are so many solutions. There are actually an infinite number of solutions. So to determine more solutions, you can just go around the unit circle as many times as you want. And then you would determine a new solution each time. Okay? So as I said before, in the question, normally we would specify the domain. Like, let's say if my question is asking you, give me the solutions of sine x equals to root 3 over 2, between 0 and 4 pi. And so therefore your answers would be, let me just see if I can still make sense of my notes. And if my question is asking you to give me the solutions between 0 and 4 pi, right? So your solutions would be, okay, this guy, right? We have found this guy was one of the solution, right? The earliest one, pi over 3. The second one would be 2 pi. No, sorry, pi take away pi over 3. So this is this guy, right? Then we found another one here, and then we found another one here. So there are 4 solutions between x greater than 0 and less than 4 pi. And you can also go in the negative direction. So my question can be, give me the solution between 0 and negative 2 pi. And how about you go ahead and do it? All right, have a go. I will put the answers on the next slide. The working out from the last slide was very messy, so I figured I would just include the notes here so you have the neater version of the note. And I also asked you to do a question, which is to work out if we go in the negative direction. So between negative 2 pi and 0, what are the solutions for the equation? And if you have done it properly, you should have found these two. Because we know these trig functions will repeat themselves, so the values are going to repeat themselves, except sometimes the signs would change. So we can work out a system for us to work out the signs of each quadrant. I like to call this the cast diagram. In this textbook I copied it from, they call it ASTC. I don't like to use that. I just like to call it cast. It makes more sense to remember cast, but you just need to remember it starts from the 4th quadrant, CAST. Basically what it is saying is, actually, so remember this is the 1st, 2nd, and 3rd and 4th quadrant. Don't mess that up. So in the 1st quadrant, this A tells me all the ratios would be positive, which means if I've got an angle here, cos theta would be greater than 0, would be positive. Sine theta would be positive. Tan theta would be positive. That's what it means. The memory is starting to come back from last year. So let's look at the 2nd quadrant. What does this S stand for? It stands for sine is positive. So which means if I've got an angle here, only sine of that angle would be positive. If I take the tan or the cos of that angle, I will end up with a negative number, and so on. So this one only tan is positive, this one only cos is positive. That's how you use this cast diagram. You can use it to work out the signs at each quadrant. So how do you use it? We need to first use something called a reference angle. So the reference angle is the arbitrary angle theta, which is an acute angle. Acute angle, remember, is an angle less than 90 degrees between theta and the x-axis. So you always want to talk about the angle between this guy and the x-axis. So if we have an angle here, we're going to use this as the reference angle, not this one. If we have an angle here, we're going to use this guy as the reference angle, not that one. Okay, so it's always the angle stuck to an acute angle next to the x-axis. 3rd dot point, the value of the trig ratio is the same as the value of the reference angle. So what it's saying is the value would be the same. So for example, if I've got an angle here, okay, and I've got the same angle but on the other side, if I take the cos of this angle, the value would be the same. If I take the sine of this angle, the value will be the same. If I take a tan of this angle, the value will be the same. It's just talk about the value, not the sine. The sine, how do you work out a sine? You use the cast diagram to work out the sine. So in this case, if I've got an angle here, I can say cos theta, let's say this is at 1st quadrant, cos theta would be positive. At the 2nd quadrant, cos theta would be negative, right? So this guy at here, if at the second quadrant, I would have negative cos theta. The answer is going to be negative, right? So that's how you use this cast diagram to work out the signs of your trig functions. Let's see how we can use it in action. So let's do a few examples. The question is asking you to express each expressions in terms of an angle between 0 and 90 degrees. So we want it to be in terms of between 0 and 90 degrees or 0 and pi. Sometimes you might want to draw yourself a picture, right, where is 125 degrees, or if you're good with your mental math, you won't be using your calculator for any of these questions. If you're good with your mental math, you can just work it out like that. So 125 degrees. 125 degrees would be around there. That's 125 degrees, right? Greater than 90, less than 180. So I'm working on question A. What would you do? You want to express it in terms of 180. So what's 125 in terms of 180? So 125 degrees is the same as sine 180 take away 55, right? So this angle is the same as if I go all the way and then I move back a little, right? If I go all the way, that's 180 degrees, and then I take away 55, I would end up at 125, right? So you can write that as sine 180 degrees take away 55. And what else do you know? Because I want it to be in terms of an angle between 0 and 90 degrees. So I actually want us to represent it in terms of an angle over here. So what would give us the same answer as here? So we have an angle here, like we know this is the angle that we are talking about. But how do I express it in terms of an angle over here? Remember, we can use our cast diagram, right? Because we know at the second quadrant, sine is positive, and at the first quadrant, sine is also positive, right? So which means, if I know this is 55 degrees, and then I take the sine of this, it would be the same as this guy, right? Because they are both positive. They're positive here, they're positive here, which means it will be the same as sine 55 degrees, right? Very important that you can do these questions. Let's do another one. Let's do part B. Cos 9 pi over 7. So what's 9 pi over 7? So this is pi. Pi is 180 degrees. So 9 pi over 7 is a little bit more than pi. So like 9 pi over 7 would be an angle over here. Okay? So which is the same as pi plus what? Pi plus 2 pi over 7, right? So this angle, this is pi. And this bit would be 2 pi over 7. So I want to express this in terms of 2 pi over 7 here. What do you use? We use the cast diagram again. Right, C-A-S-T. We know at the third quadrant here, cos, is it positive or negative? Cos would be negative. But here, at the first quadrant, cos would be positive. So the signs between first and third, if you're talking about cos, they would be different, right? So if I have this angle at the third quadrant, is going to be the opposite of the same angle, cos 2 pi over 7 at the first quadrant. So your answer would be negative cos 2 pi over 7, because you can see the signs are opposite between these two quadrants. So now we'll work on C. Okay, again, we want to express it in terms of, we're going to work on this one, we want to express it in terms of 180 degrees, right? So 10 negative 730 would be the same as, well, 18. So you'll get 720, right? Like 4 times. So you're going 4 rounds, and then you take 10, right? So this is the angle, right? You go 4 rounds, and then you take another 10. Sorry, it would be here, first quadrant. Oops. So you're going 730, which means you're going this way, 4 rounds, and then a bit more, so it will be here, negative 10, right? So let's draw a proper picture. Right? So what will you use? Again, we want to represent it in this quadrant, but we need to look at the signs, C-A-S-T. So we know that 10 would be negative here, but would be positive here. So the signs have to change, right? So we're going to have negative 10 of 10. That would be your answer, right? Let's do the last one. Just rub this up. Oh, give me a bit of space. Okay, let's do the last one. 10, oh sorry, sine of 28 pi over 3. So you want to express it in terms of multiples of pi, right? So that will be the same as sine 9 pi plus pi over 3. Go back to your fractions, right? So 9 lots of pi plus another 1/3 of a pi. Okay, so let's draw it. So 9 lots of pi's, that would be, you end up here, and then plus 1/3 of a pi. So this is the angle that we're talking about. This is your pi over 3. And we want to express it in terms of an angle of pi over 3. And which trig ratio are we talking about? We're talking about sine. So let's look at CAST. At here, it should be a negative. At the first quadrant, it should be a positive, which means the sign would flip, which means your answer will be negative sine pi over 3. Nothing that I'm doing is new, all right? You might have learned it another way. You might have been explained by another teacher differently last year, but whatever I'm doing here, nothing is new. If you think this is the first time you've heard of it, please go back to your notes last year. Okay? I don't have time to keep going on this topic, but this is the fundamentals. You need to really understand this bit for us to keep going. So these are the standard values that you need to remember. They're not on your formula sheet, and chances are it will come up in your non-calculator exam. So I'm going to write a big star here, and you need to memorize it. Please memorize it. Work out your own way of memorizing it. The way I memorize it is when I go to I know I need to memorize 0, 30, 45, 60, and 90 degrees, right? If I'm doing sine, the numbers are going up, so it's 1/2, and then root 2 over 2 and root 3 over 2, so it's 1, 2, 3. That's how I remember it. But I know the 2 and the 3 are square root 2 and root 3. But cos goes down from 3 to 1. So 3, 2, and I know that 3 and the 2 are square roots, but the 1 is just 1, or the square root of 1 is just 1. So that's how I remember it. For sine, it's 1, 2, 3 over 2. For cos, it will be 3, 2, 1 over 2. And tan, sometimes I just work it out because I use tan. I know tan is sine over cos. So I don't really memorize it, but I just work it out. So you can work out your own system in remembering these things. But if worse come to worse, if you can't remember in an exam, draw yourself those triangles to work it out. Alright, so let's do a few questions. I always would draw myself a cast diagram just to make my life easier. Okay, so I'm just going to draw it here. Sine 300 degrees. So draw yourself a picture. Sine 300 degrees would be around here, right? Which is the same as if you go all the way and then take this bit. So this is, if this is 300 degrees, this would be 60. Right, because one full revolution is 360 degrees. So sine 300 is the same as 360, take 60, right? So I want to express it in terms of 60 degrees in the first quadrant. So look at the cast diagram. Sine would be negative here. Sine would be positive here, which means the signs would flip, which means I'm going to end up with negative sine 60 degrees. What is sine 60 degrees? Is root 3 over 2. Root 3 over 2. And remember the negative sign. So my answer would be root 3 over 2. This would be in your non-calculated exam. So you need to know that. Let's work on B. What's cos 7 pi over 4? So we're going to express it in terms of 2 pi. Right? 7 pi over 4 would be, again, it would be, if the whole revolution is 2 pi, so 7 pi over 4 would be here, which means I would have a pi over 4 here, right? So I should have drawn right in the middle. Anyway, it doesn't matter. So, which means it's the same as cos 2 pi, take away pi over 4. So I want to express it in terms of a pi over 4. Cos, let's look at the fourth quadrant is positive, and the first quadrant is also positive, which means the sign won't change. It will be the same as cos pi over 4. And what's pi over 4? Cos of pi over 4 is root 2 over 2. Do one more. Let's try tan of negative 210. So again, draw yourself a picture. If it's negative, it means you're going in the negative direction. You're going clockwise direction. So if you go here, that's 180 degrees and a little bit more. So tan and negative 20 would be here. That's negative 10 degrees, which is the same as you go negative 180 and then you take another 30. So it's the same as 180. Negative 180, take 30, right? So which means this angle here is 30 degrees. So how do I express this in terms of 30 degrees in the first quadrant? Let's have a look. So tan would be negative at the second quadrant, but it will be positive at the first quadrant, which means the sign would change. So it equals to negative tan 30 degrees. I don't really need to write the degree sign, just write tan 30 degrees. And what's tan of 30 degrees would be root 3 over 3. Remember the negative sign, and that's how you do it. Just some useful tip, you can simplify expressions like sine x plus 3x over 2 or cos 7 pi take x by treating x as if it was an acute angle. And then you can remember sine and cos, they will swap over for odd multiples of pi over 2, right? We'll do 2 quick examples to finish this lesson. Simplify each expression. So we want the answer to be as simple as possible in terms of x. We don't want anything before it or after it. We just want a trig function with x. Okay, so let's look at question A. Tan 900 take x. So what you need to do is you think about what is 900. You're going to express it in terms of a multiple of 180, right? Because you know about the periodicity of these trig functions. You know they repeat themselves. So 900 is just 5 times 180, right? So 10, 5 times 180 degrees, take x, right? So it's just the same as 10, 180, take x. Because you don't need the 5 times before, because you know they repeat themselves. So draw yourself a picture. 180 degrees is here, take x, so 180 degrees, take a little bit of x, so we're talking about angle here. Okay, what do you do next? Cast, right? Because we want to express it in terms of an angle at the first quadrant. At this quadrant, at the second quadrant, would 10 be positive or negative? Well, 10 would be negative here, right? Negative 10 here. At the first quadrant, 10 would be positive 10, right? Which means the signs would flip. So if I need to express this in terms of just x, it's going to be negative 10x because the signs have changed from here to here, right? So your answer would be negative 10x. Let's do one more. Sine pi take x. So obviously again when we ask you to simplify, I don't want this pi take away. I just want something x. So draw yourself a picture. Pi is 180 degrees, so it's here. Take away x. So this would be my x. What would you do next? You check the sign, right? Because we want to express it in terms of an x at the first quadrant. CAST, use your cast again. Sine, second quadrant is sine positive or negative? Well, positive sine. First quadrant, also positive sine. So really, you can just write sine pi take x equals to sine x because the sign wouldn't change, right? So your answer is just sine x. So what have we covered? After today's lesson and your self-studies, you should be able to recall sine, cos, and tangent as the ratios of sine lengths in right angle triangles. So that's just SOHCAHTOA. And also, we went through a revision on what you should have learned from last year, the unit circle, right? And then from the unit circle, we developed cos, sine, and tan. And then we used the fact that trig functions would repeat themselves, or we call it periodicity, to work out the angles. And also we are able to convert between degrees and radians. Alright, so you need to be quite familiar with the first 2 dot points at the end of this session. Next lesson, we're going on to the 3rd dot point using the sine rule, cosine rule, and the area formula to find a triangle. Alright, this is the work that you need to do. Have fun, take care.